At the very heart of our galaxy lies a mystery that has fascinated astronomers for centuries. From ancient skywatchers who saw a faint glow in the direction of Sagittarius, to modern radio telescopes that pierce the dust, the quest to identify what truly resides at the Milky Way's center has been a saga of curiosity, ingenuity, and relentless observation. The first clues emerged in the early 20th century, when astronomers noticed that stars near the galactic core moved at astonishing speeds. Spectroscopic measurements revealed velocities far exceeding those expected from visible matter alone, hinting at a massive, invisible presence exerting a powerful gravitational pull. In the 1960s, radio astronomers tuned into a bright, compact source known as Sagittarius A. This radio beacon, shrouded by thick interstellar clouds, emitted a steady glow that seemed to emanate from a single point, a tantalizing hint that something extraordinary lay hidden behind the veil of dust. The breakthrough came with the advent of infrared astronomy. By observing at longer wavelengths, scientists could see through the obscuring dust and map the distribution of stars within the central bulge. These infrared surveys revealed a densely packed region of old, red giants circling an unseen mass. The turning point arrived in 1995, when a team led by Reinhard Genzel and Andrea Ghez began tracking individual stars orbiting the invisible center. Using adaptive optics to correct atmospheric distortion, they measured the orbits of stars like S2, which whizzed past the central point every 16 years at speeds approaching a few percent of light. From these precise orbital calculations, the mass of the central object was determined to be about 4 million times that of our Sun, confined within a region no larger than our solar system. Such density could only be explained by a supermassive black hole, a singularity where gravity is so intense that even light cannot escape. But a black hole is not a simple sphere of darkness. Surrounding it is an accretion disk of superheated gas, magnetic fields, and relativistic jets that can fling particles outward at near-light speed. Though Sagittarius A** is relatively quiescent compared to the blazing cores of active galaxies, occasional flares betray a restless environment. To capture these fleeting flares, astronomers turn to space-based observatories. The Chandra X-ray Observatory recorded sudden bursts of high-energy photons, while the European Southern Observatory's Very Large Telescope monitored near-infrared spikes, together painting a portrait of a dynamic, ever-changing heart. The story of the Milky Way's core is not solely about a black hole. It is also a bustling stellar metropolis. Within a few parsecs of Sagittarius A** lie massive star clusters, such as the Arches and Quintuplet, whose newborn, massive stars blaze with ultraviolet radiation, sculpting the surrounding interstellar medium. These young, hot stars pose a paradox. Their formation so close to a supermassive black hole challenges conventional theories of star birth, which require relatively calm, dense molecular clouds. Researchers propose that these stars may have formed farther out and migrated inward, or that extreme tidal forces can compress gas in unexpected ways. Beyond the stars, the galactic center hosts a complex web of molecular clouds, filamentary structures, and magnetic fields. Observations in millimeter wavelengths with the Atacama Large Millimeter/Submillimeter Array, ALMA, reveal streams of cold gas spiraling toward the black hole, feeding it slowly over millions of years. The interplay between the black hole's gravity and the surrounding environment influences the entire Milky Way. Periodic outbursts can drive energetic winds that heat the galactic halo, regulate star formation, and even affect the distribution of dark matter within the inner galaxy. In recent years, the Event Horizon Telescope has pushed the frontier further, linking radio dishes across the globe to achieve Earth-size resolution. In 2019, the collaboration captured the first image of a black hole's shadow in the galaxy M87, and the same technique is now being refined to image Sagittarius A** itself. Future missions promise even deeper insight. The James Webb Space Telescope will probe the infrared spectrum with unprecedented clarity, while proposed X-ray interferometers aim to resolve the innermost accretion flow. Each new instrument brings us closer to answering lingering questions about the spin, growth history, and ultimate fate of our galactic nucleus. Thus, the center of the Milky Way is far more than a single point of darkness. It is a dynamic laboratory where extreme physics, star formation, and galactic evolution converge. As we continue to peel back the layers of dust and distance, we not only learn about the heart of our own galaxy, but also gain a window into the hearts of countless others scattered across the cosmos. Beyond the glowing filaments of ionized gas, astronomers have uncovered a population of massive, young star clusters that thrive in the galactic nucleus, their intense radiation carving cavities in the surrounding dust and shaping the flow of material toward the central black hole. These clusters act as cosmic beacons, their infrared brilliance allowing us to map the three-dimensional structure of the central bulge, revealing a surprisingly bar-shaped distribution that twists and turns like a stellar ribbon. At the very heart lies Sagittarius A*, a supermassive black hole whose mass rivals 4 million suns, yet its event horizon is no larger than our solar system, a paradox that challenges our understanding of gravity under extreme conditions. Recent observations of stars orbiting within a few light-years of Sagittarius A** have provided the most precise test of Einstein's theory of general relativity, confirming subtle precessions predicted over a century ago. But the black hole is not a quiet void, it sporadically awakens, flaring in X-rays and radio waves as stray gas spirals inward, offering a fleeting glimpse of the violent accretion processes that power quasars across the universe. These flares also generate powerful jets of relativistic particles, which, though modest compared to those of distant active galaxies, still influence the chemistry of nearby molecular clouds, seeding them with rare isotopes. The central molecular zone, a reservoir of dense gas stretching hundreds of light-years, serves as both fuel and cradle. It feeds the black hole while simultaneously birthing new generations of stars in a feedback loop that regulates the galaxy's growth. Within this zone, astronomers have detected massive filamentary structures, some spanning dozens of parsecs, whose magnetic fields appear twisted into helical patterns, hinting at a hidden dynamo that may channel energy across the core. These magnetic highways could guide cosmic rays, high-energy particles that permeate the galaxy, through the inner regions, affecting everything from the ionization state of gas to the rate at which stars can coalesce. On a larger scale, the Milky Way's central bar rotates like a cosmic stirrer, funneling gas inward and setting up resonances that trigger bursts of star formation every few 100 million years, a rhythm echoed in many spiral galaxies. These periodic bursts leave behind stellar populations with distinct chemical fingerprints, allowing us to read the galaxy's history like a layered manuscript, each generation preserving clues about past inflows and outflows. Beyond the Milky Way, the insights gathered from our own core serve as a template for interpreting the faint, dust-obscured nuclei of distant galaxies, where direct observation remains a formidable challenge. Future missions, such as the next-generation infrared interferometers and space-based X-ray observatories, promise to sharpen our view, potentially imaging the event horizon itself and tracking gas streams in real time. As we stand on the brink of these discoveries, the hidden heart of the Milky Way reminds us that even in the darkest corners of our universe, light, whether from stars, gas, or gravity, continues to illuminate the story of who we are.